Okay, so when you picture wind power, you probably think of those giant three-bladed turbines, right? The ones you see spinning on hillsides. But what if the future of wind energy looks nothing like that? Today, we're diving into some really cutting-edge ideas that could totally change how we harness the wind.
So let's just kick things off with a huge question. What if you could get electricity from the wind without a single gear, blade, or spinning part? It sounds a little like science fiction, doesn't it? Well, it might be closer to reality than you'd guess.
But, to really get why we even need these wild new ideas, we first have to talk about the challenges facing the tech we're all so familiar with.
Now, don't get me wrong, traditional wind power is an absolute beast when it comes to green energy. Globally, it helps us avoid putting over 1.1 billion tons of CO2 into the atmosphere. It's a proven, seriously powerful tool in the fight against climate change. But it's not perfect.
Okay, so here's the classic trade-off. On the one hand, yeah, you get tons of clean, scalable power. But on the flip side, these turbines have massive upfront costs. They need maintenance checkups a few times a year, and let's be real, their size and the noise they make can be a big deal. And that's exactly where the door opens for innovation. So, our first alternative, honestly, it sounds like something straight out of a futuristic movie. We're talking about a technology that literally generates power from charged particles just moving through the air. The science behind it is called electrohydrodynamics. Yeah, it's a mouthful, but the idea is actually pretty simple. It works kind of like those old ionic air purifiers. You create charged particles, you let the wind blow them from point A to point B, and that movement of charge, well, that is an electrical current. All of this with zero moving parts. That's why it's called a solid-state device. And get this, it's completely silent. So how does it actually work in practice? It's basically a three-step deal. First, you've got to create charged particles. An early concept for this used water droplets, but newer versions use emitters to release ions. Second, the wind does its thing, blowing all those charged particles past a collector array. And third, that flow of charge creates a current you can just harvest. Simple as that.
And what's so cool is that this isn't just some theory stuck in a lab. The Dutch wind wheel, this huge architectural project planned for Rotterdam, is actually designed to integrate this silent, bladeless tech right into its core. I mean, it's a vision of how our cities could generate power without us even noticing.
Okay, so from a technology with literally zero moving parts, let's pivot to something totally different. Something that harnesses a very specific and usually a very unwanted kind of movement. You see, in the world of engineering and architecture, there's this vibration that wind can cause, and it's seen as a seriously destructive force. It's the kind of thing you spend millions of dollars on to design bridges and skyscrapers to avoid at all costs. But what if you did the exact opposite? A Spanish company called Vortex-Bladeless looked at this destructive force and saw a huge opportunity. They decided to just lean into it and figure out how to turn a massive problem into a power source. This whole phenomenon is called vortex-induced vibration. As wind flows past a cylinder, it creates these little swirling vortices that can make the object start to oscillate or wobble. And if the frequency is just right, those vibrations can get incredibly powerful. In fact, this is the very same effect that famously tore apart the Tacoma Narrows Bridge back in 1940. So what Vortex-Bladeless did was design a mast that intentionally resonates with the wind to generate electricity from that wobble. Now here's the trade-off. It captures less of the wind's total energy, so it's not as efficient as a giant turbine. But the upside is huge. By getting rid of all the complex mechanical parts, the gears, the blades, all of it, they estimate it could generate power for about 45% less cost. That is a massive, massive reduction.
All right, so we've gone from the totally sci-fi to the wobbly mast. Now let's bring it all down to earth, literally to our own homes and cities, with some ideas that reinvent the turbine itself.
So let's check out a couple of the most promising designs for you and me. First up, you've got the ice wind turbine. It uses these really simple scoops that are incredibly durable. We're talking it can handle winds up to 130 miles per hour. Then there's the helium PowerPod, which does have a blade, but it's completely contained, which makes it super safe for rooftops. Plus, its unique shell actually funnels air into it, accelerating the wind by 40% before it even hits the blade. And here's the big advantage for both of these systems. They're the perfect partner for solar power. Sure, they might cost more upfront than solar panels, but they generate power day and night, whether it's rainy or sunny. In a lot of cities, a device like the PowerPod could actually produce more power than a solar panel system of the same size over a whole year. It could really lead to a reliable home energy setup.
So, after looking at all this cool new tech, what does it all mean? What does the future of wind energy actually look like?
Well, the key takeaway is this. There isn't going to be one single winner. The future is all about having a diverse portfolio of technologies. You might see those silent, solid-state systems built right into massive buildings. You could have farms of low-cost, vibrating masts out in open areas. And our city skylines might start to fill up with safe, contained turbines on every rooftop. Each one of these has its own perfect place.
And that kind of brings us to the final question for you. Looking at all these different paths forward, which technology makes the most sense to you? The oscillating mast, the rooftop PowerPod, or the silent ion windmill? The choices we make could really shape the look, the sound, and even the feel of our cities for decades to come.